tutorial of MATLAB, and today we are going to see how you can create a movie plot in MATLAB. In past, we were doing static plots where you plot a function and finally you get the final image of that plotted function within the range of the associated variables. But now maybe sometimes you need to create figures such that you can see the changes in the function based upon the changes in the variables involved in that function, and you want to see all of them in one figure in the form of movie. That can be done using movie plots in MATLAB, and the idea is that the changes are captured in different frames, and then those frames are put together in the form of movie, and whenever you open that figure you will see the figure that looks like a movie. So let's get started. First we'll create this figure. Let me dock it first, and now you can see here line 10, it says z is equal to peaks. So peaks is the function that we want to use in this tutorial. Before getting started, let me tell you what this peaks function is. So the peaks function is useful for demonstrating graphics functions such as contour, mesh, p-color, and surfaces, and it is obtained by translating and scaling Gaussian distribution and is defined as this lengthy function. Okay, so we are going to use surfaces in this tutorial to explain how we can create a movie in MATLAB. So that's why we are taking this function as an aid to demonstrate how we can do that. So let's first see how this peak function looks like. So you can see z is equal to 49 by 49 matrix. When we open it, we can see it's a 49 by 49 matrix. So it calculates this, and then we can use it further in our tutorial. So let's first make this surface z using these variables 49 by 49, and it would be one surface along z-axis. So you can see this figure. So we are going to make use of this. Currently what you can see is that there are some gaps at these corners here and here. So to make this figure looks nice and well fitted within the frame that you are seeing on the screen, we can use a command axis tight manual. And what it does is that you can see now it looks really nice fitted within the corners of this figure block that you can see. So that's why we use axis tight manual command. And axgca is basically, it returns the axis for standalone visualization basically and within the current figure, and remove all the axis objects whose handles are not hidden before adding new objects. So it does not reset figure properties, and it is equivalent to another command in MATLAB, which is clf. So basically why we are going to use this ax is equal to gca is because we want to preserve the axis properties. And in movies, as I already gave you an idea, that we are going to capture frames, and those frames are put together to create a movie. Therefore every frame should have same properties so that the figure looks nice. So that's why we are preserving these properties here, ax is equal to gca, and then using it using same properties in all those frames or all those coming up figures. So that's why we are using ax dot next plot is equal to replace children. Basically it is going to use the same properties that the current plot has for its axis. So we have run this line 16. Now loop 40 means that you want to run 40 loops and you want to create 40 different variations in this plot. So that's why you want to specify this variable. And basically when MATLAB is recording the video, it is making use of a specific structure, and that structure has two columns. One is C data and the other is color map, and it will have certain rows, and for each row it will capture, or it will create a different frame for it. So let me run this first, then we'll see how it looks. So m loops is basically taking the length of loops to create this structure. So when I run this, you can see this m structure is populated, and it has rows number equal to 40. You can see there are 40 rows in it. When I go down, there are 40 rows, pre-populated rows, and there are two columns, C data and color map. That is what movie is going to make use of. Currently it is empty, but when the loop will run, each of it would be populated one by one. H dot visible off is basically when you are running this loop, you are going to run it 40 times. So every time it runs, you don't want to see the variations here. If you don't want to see the variations here, you will make this H dot visible is equal to off. So once the figure is plotted, then you are going to see the variations, but during that process it is not going to show you the variations. I'll show you an example with H dot visible on or without turning it off. By default it is on. Without turning it off, you will see the variations in the screen. Now for j is equal to 1 2 loop, so you are going to run this for loop for 40 times, and then x is equal to is a function of j, z and pi. That is what you are going to calculate. And then surface x z is going to draw this surface which has first element x and second element z. And then draw now is a function that by default captures 20 frames per second, 20 times per second. So whenever the fraction is 1 second by 20 times, it captures 1 frame, and if it is less than that, it will not capture. So that is by default. In next few steps, I'll show you how you can change this rate of capturing the frames and how you can increase the length of the movie. But for now we are using this draw now, which is by default command, and it will capture based upon the specifications within the MATLAB. And mj get frame is going to populate this m structure here that I have just shown you. So every time this loop will run, the structure is going to populate. Okay, so now let me run this loop and you will see now you will see this m here. It is currently running, so it will take some time to populate. You can see the C data is going to populate for all of these loops. So if you stop it at let's say first loop, you will only see this first row being populated. However, this color map by default is going to remain empty. Now h dot visible, you will do it on, and then you will run a movie, and then within the brackets m. This is the by default the command. M is the structure that you have populated. If the structure name is different, you will call it with a different name. Doesn't matter. However, the structure internally looks like this structure m. So if I run these two lines, so you can see here this figure. Okay, so this is now in the form of a movie, one figure that you can see. Now next thing that I mentioned is you can control the speed of the figure, so speed of the movie. So until this point, before running this loop, you will have this everything same. So let me run this again, and now within this for loop, you can see it is still same. But when you plot this movie, you can use this. Now the next thing that I want to specify is how you can control the speed of this movie. So you can change the speed. As I already said, by default you can use draw now to capture the frames, and then you can use movie m here. There are various ways you can do it. The first way is you can, when you are calling this movie function, movie, then within the brackets m, now you are using comma 1 comma 6. So this 6 means that you are using 6 frames per second. Okay, so let's run this section and you will see a different speed. Okay, so now you can see here the speed is slow as compared to the previous one. If I choose it to be, let's say 20, and if I plot it, let me do it again. You can see it's pretty fast. So that is how you can control the speed. You can type any value here, and that is basically the number of frames per second, and then the movie speed is going to change accordingly. Now, as we saw in the previous section that we were using here, this command h.visible is equal to off. Now if you don't use it, that means it's on, and if it is on, then you are going to see the variations in the figure while it is being calculated. So let me run this one here. The only difference here is that you can see this is the off command is not there, so that means by default it is on, and it is movie rate is by default based upon 20 frames per second. So if I run this, you will see while calculating, and now it is second time it is running for this movie. Okay, let me run it again. So for the first time you will see the animation, it is because it is being calculated and that is being shown in the figure, and the second time it is animated is because you are using this movie M, and now it is based upon the predefined rate, it is again showing you that movie. So let me run it again. This is the calculation, and now this is the movie. This one is the movie, sorry. Yeah, this one is the movie. Okay, the next thing is that if you want to play some of the frames, let's say twice, you can do that. In certain parts, let's say you want to rerun the third frame 2 times or fourth frame 3 times, you can do that. So the rest of the commands of capturing the frames until here are fine, are similar to what you were doing in past. You can do h.visible off or on, depends upon you. And here you will have to give this command movie M, then within comma you have to specify this 2 means that how many times you want to repeat the frame. This should be in square brackets, and then which frames you want to repeat: 1, 15, 23 and 36. These are the 4 frames that we want to repeat 2 times, and this specifies the frames per second speed. So let's say we want 12 frames per second. So this is how you can create a customized command where you can repeat some of the frames and you can specify your speed as well. Let's run it. So you already seen there are 12 frames per second, and there are some frames which are repeated. Definitely you can't say it from just seeing the movie that frames are being repeated, but if you really know the function and you really know the values, you can always understand that the frames are being repeated. We can change the speed, and we can try to see it slowly. Let's run it for 1 frame per second, and so now you can see. Okay, so that is how you can repeat some frames. Now if you want to keep this, like for example this is the figure, if you want to keep this figure as there and play movie somewhere around here on the top right corner, you can do that, or maybe at some other place. So basically you can specify the location where you want to play the movie. So until here again the commands are same, but this last one where you are going to hit this movie command, you will say movie H, which is basically the movie. This frame that you're going to specify movie H comma M, then comma 1 comma 12. This 1 and 12 are the speeds and the repetitions for this frame. So basically you don't want to repeat it, and there are 12 frames, and then this is the location actually within square brackets 30 30 0 0. So 30 30 and 0 0 are the first 2 are X and Y, where these last 2 are the just part of command. These are not being used here. You just have to take care of this 30 30. 30 is the offset from x-axis, and the second 30 is offset from y-axis. You can do it negative as well, but in that case the movie is going to shift in the negative quadrant. So we will see that example as well. So in this current example, this is 30 30. Let me increase it a little bit more so that we can see it more visibly. So let's run it. 9090, it is offset 9090. Remember this 9090 is in pixels. So you can see it is 90 pixels towards this right side. So it is shifted 90 pixels towards top, towards positive x-axis, and 90 pixels toward the positive y-axis in this main figure. We can do it in reverse. Let's say we want to have negative minus 90 and negative minus 90. Now you will see the figure is shifted towards the negative x and y axis. So when you see, okay, yeah, here you can see it. Similarly, if you want to increase it, let's say minus 180 and minus 180, you will see the shift with a different magnitude. Okay, here you can see it. So that is how you can shift it. If you want to shift it a little more towards top, or if you want to see it this on the background, you can do that, and that's up to you. This is the customized command you can do for this feature. So that is all for today. I hope this video will help you. In case if you have any questions, please write them in the comments below, and I will try to answer in comments, or maybe if in case the video is required, I will create a video for you guys. And if you like this video, please don't forget to subscribe to my channel and like my video. We'll see you in the next video. Till then, bye bye.